Welcome, everybody. I would like to introduce you to Jacques Fouet and André Engelbrecht, who will be talking to you about AI-powered assessments, instructional strategies, and adaptive feedback today. The talk will be 40 minutes, and we'll see if we have time for a short Q&A at the end. So let's give it a warm welcome.
Thank you, Tim. So today we're going to discuss AI-powered formative assessments and personalized feedback. So just for some quick introductions, my name, as mentioned, was Jacques, and I'm a learning architect at Construct Education. So I specialize in all things AI, with a particular emphasis on rooting emergent learning technology applications in evidence-based practices. I'm going to hand over to my colleague, Andre.
Hello everyone, my name is Andre. I am a learning technology specialist, and I'm basically going to demonstrate the assessments that we're going to be talking about today.
Thanks, Andre, and which you developed. So just to get started, and the clicker is not working.
Is it not? Okay.
Okay, so I remember when I used to work as an educator in a range of different educational organizations, I always had this issue in which I was not able to provide my students with meaningful feedback because I was always overworked. I had to mark too many essay submissions, and I often found myself providing feedback such as, well done, excellent response, good, requires some additional work. And I believe we all have received similar feedback at some point in our life, and it's highly frustrating because it doesn't promote learning and it doesn't foster growth within our students. We are going to discuss today how AI-powered formative assessments function as a solution for this issue, as well as other organizational and educational problems. So firstly, scalability. Manual grading is a highly resource-intensive process. And AI-powered formative assessments can free up educators to perform more bespoke functions within learning experiences, meaning that they do not need to do rote marking, but they can rather provide students with personalized support to promote individual growth within the learning experience. And initially, before today, we phrased it as business problems, but we rephrased it as organizational problems because we were quite inspired by the talks earlier today. And AI-powered formative assessments can really foster growth in educational context that lacks the necessary resources to foster that type of individual growth within student communities. Next, human bias and grading. We often talk about the issues associated with biases within AI algorithms. For example, that they perpetuate stereotypes, especially related to identities that are representative of the global South. However, we rarely talk about human bias within grading and with feedback generation. Human bias is also an issue. When it comes to human bias, there are multiple uncontrollable variables. But when it comes to AI algorithms, we can control those variables to ensure that we get reliable output that fosters growth within our learners. Next, feedback delay. Evidence-based practices indicate that immediate feedback improves motivation and engagement. Usually, if a student will submit an essay and it is human graded, there would usually be a delay of 2 to 3 weeks until they receive feedback, and then the learning experience, especially if the assessment is formative, is less effective. Next, we're going to focus on some rule-based grading considerations. With rule-based grading, I would like you to think about multiple choice question sets, matching questions, multiple select questions, kind of your stock standard MCQ knowledge checks that form part of most LMS learning experiences. Firstly, it's also a highly time-consuming process to develop feedback for these MCQ question sets. So imagine, for example, that you need to develop 10 questions and you would like to have answer option level feedback for each question. That means that you need to develop 40 feedback items. That's also a highly time-consuming process. Next, closed questions that are associated with these rule-based auto-grading mechanisms that are integrated within LMSs. They facilitate a lack of meaningful elaboration. Meaningful elaboration is proven to improve retention, meaning that it facilitates the transference of information from short-term to long-term memory. Next, there's also reduced creativity because we present learners with a set of predefined answers, and that is not beneficial for any type of innovation. Also, character or word level identification that is utilized to facilitate feedback or to grade open response questions are highly reductive because they can't possibly cover a range of responses. So we're going to move on to discuss how AI-powered formative assessment functions as a sound solution for these organizational and educational problems. Okay, so we've got 4 benefits of AI-powered formative assessment listed. Firstly, decreased reliance on instructor grading feedback. We touched on this. What I would like you to think about is if you integrate AI-powered formative assessments within your learning experience, how can you free your staff members up to provide additional support for your learners? And we really want to encourage one-on-one tutoring. We really want to facilitate personal growth, and that results in better learning outcomes. Next, it enables the integration of enhanced question types. Question types that facilitate justifications on positions, which results in this meaningful elaboration that we spoke about earlier. And next, real-time feedback. Through the integration of AI-powered formative assessments, we can present for learners with real-time feedback so that they can monitor their understanding of a topic in real time and know how they need to adjust their learning so that they can get better results. And this also further improves engagement and retention. Lastly, personalized and adaptive feedback. We can set up these AI-powered applications to provide learners with personalized responses and adaptive feedback, which means that we can meet the student where they are to facilitate individual growth and to build on what they know. In order to ensure that our AI-powered technology and our AI-powered formative assessments are effective, we need to root them in evidence-based practices. 2 main instructional strategies that are especially useful for AI-powered technology are mastery learning and Socratic tutoring. We will unpack this in a minute, but you can really align your AI-powered formative assessments with a range of instructional strategies. Mastery learning. Mastery learning was developed by Benjamin Bloom, and it can be summarized with the following maxim. In a mastery learning experience, time is the variable and performance is the constant, meaning that the educational experience is designed to foster growth so that students can meet certain benchmarks that are set for them. Next, Socratic tutoring. Socratic tutoring refers to one-on-one student support in which critical questions facilitate deeper understanding of topics. And these 2 instructional methodologies have benefits, which we will look at next. So it is proven through empirical research that mastery learning, as well as Socratic tutoring techniques, improves learning objectives and learning outcomes. So our standard approach to education usually involves instructionism, which means theory delivery and then the application of theory within assessments. Benjamin Bloom has proven that there's a 1 sigma variation associated with mastery learning and a 2 sigma variation associated with Socratic tutoring techniques, one-on-one tutoring. And both of these instructional methodologies can be facilitated through AI-powered education technology. However, as you probably are thinking, there are also a set of challenges associated with AI-powered technology. And next we're going to look at these challenges and potential methods, means to combat these challenges so that we can mitigate common risk associated with AI-powered applications. So firstly, data privacy. This is a major concern for most organizations. We need to protect the personal information of our students. So we can combat this risk through ensuring that our API is encrypted end-to-end. What does this mean? Our API refers to an application programming interface that allows the transference of data from a third-party tool to a large language model and then the transference back to the third-party tool. We need to ensure that that is encrypted. And Andre will touch on that when he demonstrates some of the applications that we have designed and developed. Next, third-party solutions. We will also demonstrate a third-party solution. What is very important is that you review the data protection regulations associated with a third-party tool and the various tiers of a tool to ensure that it's aligned with your client's data protection regulations. Also, a bit of a hack is Cloud 3.5 API. So Cloud 3.5 is currently the strongest foundation model on the market, and it outperforms ChatGPT 4.0 on all benchmarks. A main benefit of running an API to Cloud 3.5 is that it protects student data by default, since none of the inserted information is used to train the foundation model. Next, we're going to move on to algorithm bias and hallucinations. Algorithm bias refers to the fact that AI models are predominantly trained on data sets from the global north, which often results in stereotypes of marginal identities and also a lack of representation of identities from the global south. So we can combat that through the configuration of a systems role. The systems role is a standard component of AI-powered applications. And you can think of a systems role as providing instructions for the large language model, which essentially informs the type of output that it would generate. So this is where prompt engineering practices come in. And we can intentionally provide the correct answer within the systems role so that we ensure that we create inclusive learning experiences. And then furthermore, we can also set up a knowledge retrieval tool which configures the knowledge base, meaning that we can add additional databases to our applications so that they are aligned with the targeted content. And the same solutions really also play in with hallucinations. And hallucinations refer to this fact in which AI algorithms can sometimes generate content that are non-factual, that are incorrect, that aren't justified by empirical reasoning or through inductive inferences. So this can also be combated through configuring a systems role with the correct answer, also by adding databases with the targeted content that forms part of a curriculum. And finally, the temperature hyperparameter. The temperature hyperparameter refers to a tool that affects the statistical distribution of content within the output. So if you have a low meter, for example 0.1 or 0.2, 0.3, the output would be highly reliable, it would be highly deterministic. If you have a high temperature meter, the output would be highly creative and less deterministic and a bit less reliable. So we can also combat non-factual information through configuring a low temperature reading to our temperature hyperparameter. And then instructional strategy alignment. We need to ensure that our AI-powered assessments are rooted within an instructional strategy, otherwise they are quite pointless. So we need to include our instructional strategy within our prompts, within our systems role, so that we ensure that we promote learning and we foster growth within our students. Next, content domain knowledge alignment. I think many of you also probably had this concern prior to the talk, that how can we ensure that our AI-powered formative assessments are rooted within our curriculum and it doesn't merely draw from knowledge that are present within the open domain. And this is done through configuring your knowledge base, in which you can add your targeted content domain knowledge to your application so that you ensure that it generates associated output. Also, you can configure a knowledge relevance threshold. The knowledge relevance threshold essentially determines how much information the application draws from open domain content that it's been trained on, as well as content that has been configured to its knowledge base. Next, costs. Custom solutions are often more cost-effective if you have developed a code base that can be repurposed for different applications, meaning that you can merely change the values that are within your code. And technical difficulty is the final challenge that I'm going to touch on before we go into the actual demonstration. If your team doesn't necessarily have the coding capabilities in-house, make use of a no-coding solution. And you can use third-party tools. Just ensure that it has the necessary parameters to combat the common challenges associated with AI-powered assessments. So next, we are going to demonstrate two solutions that we developed internally at Construct Education that we have embedded within OpenEdX. And the one is a custom solution and the other is a third-party tool solution. And we're going to walk you through how we have designed and developed these applications. And just to give you some background to the learning experience that we're trying to foster. So both these applications are rooted within mastery learning principles, and they target accessible hospital design to ensure that we create experiences that support students to apply accessible design practices within hospital facilities. Thanks, Andre.
Awesome, thank you, Jacques. Okay. So the first one I want to show you is the AI-powered assessment. As you can see here, it's just a basic SCORM package that we stuck in. Sorry, I don't know if you can hear me there. We have the question. We have a place for the user to input the answer. And we have a submit button that is linked to the API that will respond via the AI bot. Okay? The way we built this is we use something called a prompt engineering form. Show you how that looks. Looks like this. Okay. So it's basically an HTML page that we made where we added 3 text inputs. And with these 3 text inputs, we concatenate a string, and the string becomes the prompt for the AI bot. Okay, so we have the role, description, persona. We have the question, and we have the AI task in response to the user input. We have the temperature parameter as well, hyperparameter. And then we have the knowledge base upload feature too. Okay, Jacques, do you want to?
Thanks, Andre. And essentially what we're doing is, earlier we referred to a systems role as a means of facilitating the instructional strategy, right? And we refer to it as the prompt that is sent to the AI model that informs the type of output that it needs to generate. But through creating 3 different text entry fields, we can ensure that we meet our targets through concatenating a string value that is attached to the system's role variable. Next, we also configured a temperature hyperparameter so that we can affect the reliability of our output further, ensuring that our response is highly deterministic. And then lastly, we also included a knowledge retrieval tool, i.e. the knowledge base, in which we can attach our targeted domain knowledge that we would like the students to address, that is aligned with our curriculum requirements.
Okay, cool. Thank you, Jacques. Okay, so if I had to use this, I have already done this pre-checked. So once the information is in the form, what we do is we hit generate for storyline. It will copy a JavaScript over here. You can grab this and you can go over to storyline, and you can actually make the template pretty easily in storyline. Exactly the same as the question before. Question, user input, submit button, and AI response. So with this JavaScript, we have to stick it into the execute JavaScript spot here. I'm just going to do that quickly. Once that is in, we hit OK. And that's about it, except for one more thing, is the API key. So the API key does not sit within this JavaScript. There's a reason for that. If we did that, it would be quite easy to access through anybody that's using it. So we gave the API key a variable of token, and we used Storyline as a third-party solution to protect the API key. So there's token, there's the API key, and it will be end-to-end encrypted through Storyline. Okay. Then we publish it into a SCORM package, and we move over to edX, and we stick it on edX just like that. So to test it, if it works now, I'm going to answer the question. So the question is, mention one feature that an MRI room at Greenfield Hospital that helps create calming environment, and explain how it supports patient well-being. I'm going to say the answer is ambient lighting, and I'm going to get Jacques to speak on the response.
Thanks, Andre.
Cool.
So what you see is a response that is generated via AI. Firstly, it is aligned with mastery learning principles. So it firstly identifies what the student entered correctly within the text entry field, and then it identifies room for improvement to essentially enrich the learner's understanding. So what I would like you to consider is how this can be integrated as a formative assessment within your learning experience, and how that can facilitate individual and personal growth of your students. Next, we're going to discuss a custom solution.
Okay.
When we think of formative assessments are essential for learning growth. We want to promote learning through formative assessments. And in order to ensure that we promote learning effectively, we would like to facilitate learning experiences within authentic scenarios where the learners will actually apply their knowledge and skills. So we integrated formative assessments within a 360 virtual tour environment. And these formative assessments are AI powered and aligned with a mastery learning instructional strategy. So let's have a quick test, and then we can discuss how we set up these formative assessments to get the type of output that we are looking for.
Disclaimer. Oh yeah, cool. Nice.
Okay. So imagine the student moving through the virtual space, entering different rooms, learning about accessible hospital design leading practices, and then having the knowledge check happen within the same environment. So why are accessible sliding doors used in the hallway? Let's enter a response such as to transport patients in hospital beds.
Spelling terribly, sorry. And submit.
Okay, so now the third-party tool runs an API. This particular one runs into ChatGPT 4.0, and then it generates an output from there. We have set up certain parameters to improve the reliability of the response. Firstly, we configured a systems role that's aligned with mastery learning principles, as well as includes the targeted answer. Next, we also added content to the knowledge base, which contains all the targeted content domain knowledge that forms part of the curriculum. And then we also added a temperature hyperparameter and established a knowledge base relevance threshold. So what you can see in the response is it identifies that, yes, it is used for this particular purpose. We use accessible sliding doors to transport patients in hospital beds. But in addition to this, please consider these following reasons why we use accessible sliding doors. So that fosters further growth within our students and it enriches their understanding. From my position, it wouldn't be possible to provide this level of feedback to students with informative assessments for most learning experiences. And that is what we wanted to discuss with you today. Thank you very much for your time. Do we have time for questions?
Thank you.
Yes, thank you. Right.
Hello. Thanks, Zach. Thank you. Thank you for cautioning out the other day that this is pretty much a prototype. So congratulations, it worked.
Thank you.
I think in your last example that you just gave, right? So it did come up with some additional information and some more contextual details around it. But how do you assess it? From let's say instructor's perspective, who needs to grade the student. So how do you put some kind of a rubric around that if your answer was this in this particular case, to transport the beds from the into the hallway? But how do you create the grading of this based upon contextually what the answer the AI gave? Right. So that's one of the aspects I'm just wondering about.
Yeah, and that's a great question, and that's something that we have grappled with internally quite a bit. Okay, so just to give you some background firstly to this application and potential means of doing it. So we embedded Pickaxe AI, which is a third-party tool solution within a 360 virtual tour software. So each of the responses would be sent to the third-party tool, which the instructor can essentially evaluate. But the question that you really are asking, as well from my perspective, is do we want to attribute AI grades to student responses? My position personally is no, not at this stage, just due to the context in which the learning experience happens and that we might not have enough contextual information that we can configure the AI application to cover a range of responses. This is though possible. There are third-party tools that can enable it. For example, Gradescope can be used for it, but we are currently using it as a means to facilitate formative assessment, similar to how we would have previously utilized knowledge checks such as MCQ questions.
Yeah, I think the main context behind this was the next step, right? So
Right.
Give it back. Now, I think the context was the next, right? So in the adaptive learning space, based upon the answers and based upon the assessment, could the system then automatically identify the next level of the recommendation for the for the person? If there is a human intervention that's required, I think it kind of loses that connection. I was just trying to figure out if we are at that point.
Yeah, no, absolutely. And I'm also going to ask Andre to speak a bit about the technical details. So the human dimension can be included because the responses would be sent to the third-party tool that the instructor can evaluate. But our thoughts around that would involve a custom solution in which we were thinking about configuring switch statements in which the AI application can attribute a grade based on the user's response. But then another consideration would be integration with a gradebook. So that is something that we will work on next and is definitely something in the pipeline. However, currently our focus is on formative assessments, just because of the risk associated with AI-based grading.
And to add to that, if we did have to move into that way, I would assume if we moved into a summative kind of grading method, we could probably use the AI task in response to maybe call out a keyword and then reach out for that keyword and give it the grade it needs, like 1 grade for if you say correct or incorrect before it starts. So that would be my thinking around getting that started, but we're not there yet. We'll be there soon. Yeah.
Yes.
Do you envision an instructor or educator of some sort to be involved in this? And the reason I ask, I'm busy with a postgrad, and our professors had an issue with students using AI, and now we have to, along with your plagiarism form, you have to also disclose if and how much AI you used. And what was interesting to me is they put it to us to say, how would you feel if I graded your paper using AI and then I didn't actually read it myself? So it's just interesting, you know, if a student has an insight, and I mean, obviously a PG-JIP compared to, you know, some formative knowledge, it's different. But if a student has an insightful moment, it would be nice if the AI could pick it up and inform the instructor of that. Or yeah, you know where I'm going.
Yeah, that's a very interesting point, and that's definitely possible. And the way that you would go about doing that would be related to your prompt engineering practices, really, because you would configure your systems role to ensure that any kind of insightful response or segments within the response that are highly insightful needs to be emphasized in the provided feedback. And then the instructor would be able to view the feedback that was generated by the AI application. Yes.
I wanted to contribute a little bit to some of the questions I'm asked, and I did have a question for the presenters. I wanted to draw a distinction at first between scoring and grading, which is kind of this new phenomenon now. We talk about AI grading. Like a grade, in my consideration, is something that you get in your grade book, and it's important to, you know, your GPA, that kind of thing. Scoring is something that the AI can do, which says, hey, has this student made the right effort? Have they checked the box that the instructor thinks they need to check for this part of the assessment? And I've seen AI scoring work well. Well, I have the same hesitation about AI grading, you know, which I think is a little bit tougher. So to me, there's kind of a distinction there. My question was kind of specific. At the end of your presentation, the AI gave pretty specific feedback about like sliding doors. The student missed that the sliding doors didn't swing into walkways or into rooms. Does that come from the knowledge base? Does that come from the AI's general knowledge? Or does it come from an instructor that says, hey, the student must address these things? Because it's very specific, 3.5, to say that.
Absolutely. Yeah, very great. I really like the distinction between grading and attributing points to a response as a means of quantifying the level of the student's knowledge on the topic. So to answer your question related to where does the feedback come from, why is it so specific? So this is where the instructor would be involved in the process, the SME. So the instructional designer would collaborate with the SME to formulate the systems role. Within the systems role, there would be two key components. One would be the instructional strategy to ensure that the feedback fosters and promotes learning. Two, it will contain the targeted and correct question. And with mastery learning principles, we have set up these particular systems role to firstly identify the discrepancy between the user's input, the student's input, and the targeted correct question, and to identify what features in the user's response is aligned with the correct answer, and how does it deviate, and how the student can align their answer to be better aligned with the targeted correct answer. In addition to that, we also added background information. For example, key readings associated with accessible hospital design practices. So it's a bit of a combination of both, but like it would definitely involve a systems role as well as the knowledge base, and it would be set up collaboratively through engagement between the SME as well as the learning designer. Any final questions? Okay. Thank you very much for your time. Really enjoyed the session.
Thank you so much.